I'm going to show you how to run a passivity measurement in Microwave Office on S parameters that have been generated by EM simulation. Passivity is a great way to check your S parameters. It gives you an idea if they're physical. Now, it doesn't mean that they're accurate. If results are passive, that still could be not a great answer. But at least it gives you a little bit better feeling that they are obeying the laws of physics. This slide is taken from our new course, Planar EM Simulation in Microwave Office, which we go into all these concepts in a great detail. Urge you to take a look at it if you're interested. Basically, passivity tells you if the S parameters are generating energy, which of course you do not want for a EM type structure. The figure is attempting to show that the power can come in, the power can go out, and the power can be absorbed in the S parameter block through radiation or heating in various ways. But if that S parameter block is creating energy, the results are non-passive and we have a problem. We're in Axiom and I'm showing you a simple hairpin filter layout, which again we are going to run in Axiom and check the passivity of the answer. If I go to the passivity graph here that I've created, rectangular graph, nothing in it, I'll add a new measurement, and then I simply go to linear, passive, and I'm pointing to the EM structure that we're interested in. When I hit the simulate button, I get this answer that you see before you. Notice the vertical scale is positive. Positive number means the results are passive. You'll notice a peak here in the middle because we actually have a resonance in the filter. It's actually absorbing more energy. More current's been created and more heating. So these results from passivity perspective look good. This example you see before you is another filter on a board. This is actually used in the new course I mentioned in the lab exercises. We use this example in a number of ways. If you want to see the 3D view of it, it looks like this. The thing I'd like to point out is there are a number of ports here in this example. We go ahead and run this in Axiom. It just ran, already had the results in it. And if we look at the passivity of the structure, we get this. The thing I'd like you to notice is it's negative numbers. And this is bad. This means it is not physical. The passivity violations here are not too great. In the course, I get into this in more detail if they're still usable. But then in the lab, we actually go through how to find out why the circuit is non-passive. To give you the answer quickly, what is going on here is if we go back to the EM structure, you can see if we list the ports, these are all the ports in this project, they have various types of grounds. Some of them are grouped together, and buried in here is the reason for the non-passivity, which can then be checked. So in conclusion, check your EM results with passivity. It just takes a few seconds. It can give you a much better feeling about the results, or it can point out potential problems.